Okay, guys, so today what we're going to do is we're going to look at average value of a function. Okay, so I just put together some notes here. You can either pause the video and write them down, or you can go, I remember all of that. But I just wanted to review a couple of things because they start to get easy to confuse. Okay, we had an intermediate value theorem. And the intermediate value theorem basically said, okay, let's say you have some continuous function and it's on an interval that is continuous in here. The intermediate value theorem said it has to take on every value, every y value between f of a and f of b, that it can't skip a value. Okay, so that was the intermediate value theorem. Okay, average rate of change, that was slope. We've been dealing with slope for a long time. Okay, then we worked on the mean value theorem. And the mean value theorem, it's not for integrals, because you're going to see that we're going to have an average value, and it's going to be for integrals. So I want you to think, what happened with the mean value theorem is what it said is basically the average rate of change on an interval, that there's going to be some point on here that the average rate of change is equal to the instantaneous rate of change. Okay, so that pretty much, I'm going to look here, I'm going to try to make it as close as I can to parallel. Looks like it about right there. Maybe I better come back a little bit. Okay, that at this point right here, or I could say at this point right here, the derivative at c is equal to the average rate of change. Okay, so those are the things that kind of had, that we've been working on before. So today, we're going to look at the average value of a function. Okay. And again, you might need to stop the video. Just make a little sketch of this right here. That doesn't need to be perfect. Okay, so the average value of a function gives us the average y value of the function on a given interval. Okay, so I'm just going to start out today because we are online, and I don't want to make it more complicated than it needs to be. So I'm just going to tell you that the formula is 1 over b minus a times the integral from a to b of f of x dx. Okay, just going to give us a nice little average. Where did I put my notes? So that I know what we're doing here. Okay, maybe not. Okay, so let's look at this right here, that we're going from -1 to 3. So I'm going to say on here, going from there to there. So when I find the average value of a function, I want to say all of these y values, what's the average of all of them together? So if I could take, figure out that y value, that, infinite y values, and I add them all up, and then I take the average of it, what would it be? Okay, so that's literally what I'm trying to find. Okay, so let's try to find, this is the graph of this, and let's just use this formula for right now. Okay, so here's a and b. So I'm going to go, so for part A, I'm going to go 1 over 3 minus -1 becomes 1 over 3 plus 1 times the integral from -1 to 3, 6 minus x squared dx. Okay, so this is 1/4. Okay, the integral of this is going to be 6x minus x cubed over 3. And we are going to evaluate that from -1 to 3. Okay, now I'm going to show you guys a way to do this on your calculator. because I know that you know how to do this. You might have to do something like this by hand if we had a no calculator thing, but let's look what we're going to do here. Okay, so on your calculator, first thing is we're going to go into this window and we're going to hit Math, which is this button right over here. So I'm going to hit Math, and then I'm going to hit 9. Okay, so Math 9. And woohoo! Nice, huh? So I'm going to go from -1 to 3, and then I'm going to go down in here, and I'm going to go 6 minus x squared, and then I got to make sure that I get a dx. So then we can get the calculator to do this for us. Okay, now be careful, because what we calculated was that right there, and we didn't have the 1/4. So I can take that and I can just divide it by 4. And that is my average value. So it is approximately 3.667. Okay, and let's see where that's at. So 3.667, it's about right here. Now, you might be thinking, wait, that doesn't look halfway between here and here. But remember, here we're going up, and then we're coming down. That's going to be, of all the y values, if we found all of them, that would be our average value. Okay, now, where does the function assume this value? Well, the average value of this guy is, let me look in here, 11/3. Okay, so this right here is 11/3. Just if I think about it, 3 goes in there 3 times and 2/3 left over. Okay, so for part B, I'm going to say 11/3 is equal to, so I want to know, when does the function equal 11/3? We could have used the decimal. It's all going to come out the same anyway. Okay, so I'm going to go 11/3 minus 6, so minus 18/3. That's going to give me x squared equals 7/3. So x is the square root. Now, I'm not going to put a plus or minus because it's not going to be on the left-hand side in order to stay in the interval. It's got to be on that side right there. Okay, let's see what that is. So if I take the square root of 7 divided by 3, I get that it is about 1.528. Okay, so it's telling me that it took on its average value right around there, and that looks correct. Okay, so that is it for now. For our basics of average value, what you're going to do is you're just going to practice with some really straightforward basic problems, and then we'll get into something a little more interesting with these. All right, hope you guys have a great day. I will see you later.